su asistencia. Bueno, hoy día tenemos al profesor Hamid GholamHosseini. Él es un profesor en la Universidad Tecnológica de Auckland, de Nueva Zelanda. Él trabaja en la Escuela de Ingeniería, pero sus tópicos, y nos va a comentar, son asociados a lo que es ingeniería biomédica, ¿ya? Que es una línea que está dentro de lo que es digamos, el estudio de la ingeniería eléctrica. Y de hecho aquí tenemos al profesor, que no sé dónde está, ahí está el profesor Hernán Meyer, que es cierto, uno de los profesores que quieran trabajar esa línea, por ejemplo, pueden comunicarse con él, ¿ya? La línea de ingeniería biomédica es muy interesante porque mezcla tanto todo lo que es la línea de sensores, ¿cierto? Desarrollo de sensores, sensores bien específicos, y todo lo que es análisis de datos también, ¿vale? Así que es un tema bastante interesante. Así que el profesor Hamid nos va a explicar un poquito su entorno, su contexto, dónde está en la universidad, y después nos hablará acerca de su trabajo, ¿ya? De su línea de investigación. Nosotros tenemos un marco de colaboración bastante interesante ya desde hace unos años con la AUT, con la Universidad Tecnológica de Auckland, así que verán seguramente más de un profesor de esa universidad viniendo acá a dar algunas charlas. Hay mucho interés en la colaboración. And the trip is not so long, no? It's 10 hours from Chile to...
Yeah, about 11 hours, yeah, one flight.
So, please, Professor.
Okay. Hola, and welcome to this talk. Thank you for attending at your lunchtime in this seminar, and thanks to Gonzalo for introduction. So as you know, we are going to talk about the application of artificial intelligence in healthcare, and I just highlighted the topics that I'm going to discuss today. First, I give you a brief introduction of my university. Then we look at the history and background of the AI in healthcare. And we want to see what is the state of AI now and what is planning to do in the future. And we will go through some of the projects that we've been using AI for this project, like eye tracking, glaucoma detection, and melanoma diagnosis, and fruit classification. So a little bit of background. My university is located in the city center of Auckland, New Zealand. We have other campuses, but the main campus is in the city center. And this is a view of one of the buildings that we are using in the city center. The university has about 20,000 students and is among one of the top 1% of the university worldwide, and it has also some of high ranking in some special area. So the university has 5 faculties. One of the faculty is DCT faculty, Design and Creative Technology. So we have other faculty like health and other things, but I am part of this faculty of Design and Creative Technology. In this faculty, we have 4 schools. So my school is Engineering, Computer, and Mathematical Sciences. So that's mainly the size of our school in terms of the number of students. We have about 2,500 students, 450 international. So you are welcome to join to school anytime. And in our school, we have different departments. I am with the Department of Electrical and Electronic Engineering, and this graph shows the number of professors, senior lecturer, and lecturer in each department. So apart from teaching, we do some research. So these are the main research entity in our schools. We do work in the area of intelligent systems. There are research centers related to this topic. And there is another area, health technology. I am part of this entity, and I am part of this institute of Biomedical Technology. I am the deputy director of this institute. And then there are other areas of research that you can see. There is collaboration with this institute, with your university here. and main research topic and research area. Now we want to see what is the role of AI in the healthcare. So there are some questions about what is the situation with AI. Is that going to be helpful with related to humanities? Are they going to take over the human in the future? So how intelligent are AI? So there are lots of discussion. Are they scary or are they friendly? So you see there are lots of discussion about AI, and then some of the answer we don't know yet, but we have to see what's happening in the future. When we look at the background of AI in health care, it goes back to about 50 years ago. So they started applying the rule-based expert system for detecting and for treatment of bacterial infection. So that is the mainly first type of AI about 50 years ago that started in healthcare. And at the same time, at the Stanford University, there was a project that doing the same thing, similar thing, application of AI in biomedical and medical problems. So since then, there has been lots of transformation and improvement. So we can see AI is rapidly transforming the healthcare industry with new application. You have seen there lots of machine learning algorithm and applications. For example, in healthcare, we can see medical imaging, which now trying to, like these are some sort of medical imaging, and we have different medical imaging, X-ray, ultrasound, MRI. Now try to have computer-aided diagnosis. Instead of the specialist, we have AI algorithm try to make the diagnosis as much as possible or help with the decision support system with the specialist. Another area in the rural and remote area, there is a possibility of communicating with person through computer or through the link, and then do some sort of assessment at that site. So we have algorithm that they can monitor the vital signs and then come up with the decision about the problem with that, and then communicate with the doctors. And there is also AI can help with the prediction of the spread of the disease. In terms of COVID, we use AI to develop the vaccine. Vaccine was very important, and then normally it takes a few years to come up with the product because it needs to be tested on different subjects, and but the AI helped to make the simulation and then speed up the process. And then with the training of the healthcare workers, we are using virtual reality and AI to train and generate scenarios and then use for that application. And then overall, AI is useful with that from this aspect, reduce the cost of healthcare and improve the quality of the healthcare delivery. And now we are seeing that generative AI is coming to the place and also helping in the healthcare. So the generative AI, they are not only analyzing and interpreting the data, but they can create new content. So for example, ChatGPT, you give them a 400 words abstract and ask that to generate 1000 words. So it can generate new concept, even sometimes new knowledge and new decision. So generative AI, but at the same time requires significant computational resources, and I'll show you how much money and energy required for training generative AI. We did one project which was related to vital sign monitoring, and among vital signs we wanted to do blood pressure measurement. So we used some device to measure the PPG, which is oxygen saturation at the fingertip, and also ECG. And using this device, we developed an app. This app was able to measure the heart rate and the oxygen saturation, and we could extract through algorithm the blood pressure value indirectly. So that was something that we have done, but for this application we did on mobile app, we needed to have a lots of screens. First screen just for login, password, then the next screen to go to the next level to see what patient we want to select or what doctor we want to select. Then the next screen we want to see which device we want to communicate from Bluetooth, and then what sort of information we want to extract, whether we want to look at the history, and then finally we get to that last screen to monitor the data. But now with the use of AI, instead of going to these traditional steps, we can have just a chatbot or conversation. It asks us, what can I help you? And then someone just tell the application that I want to measure my heart rate. And then it will help that one. So you can see that with Gen AI, it can help a lot in terms of make the application user-friendly and patient-friendly and generate more information out of that. So in terms of the state of AI, what state we are, we have seen that in 2023, last year, we had really big jump in the application of AI with the generative AI. And then we have seen lots of investment in that field. So we think this trend is going to continue. I show you some of the data that I've got from IEEE Spectrum. So you see the amount of investment in billion US dollar for generative AI has significantly increased in 2023, about 10 times or more. And this is going to be continue. We are expecting when the data coming up for 2024, that investment is going to increase. So you see that how significant is this industry and this technology. And there are some companies like Google, they try to have the powerful models, foundational models. And then one thing which is with these models, when the models is getting very big and sophisticated, the training cost is significant. So normally the university or small industry, they cannot afford to have this type of models. I'll show you this graph which shows the training cost in US dollar. So some models like ChatGPT-3 with 175 billion parameters, that one it costs about $4 million to train, the cost of the training. And then when we go to the like ChatGPT-4, you see the cost of training is huge, $78 million. And Gemini from Meta, they are spending that much money for training their algorithm. So one is the training cost, and then the other one is mainly the carbon footprint, because we need lots of computational power, and the computational power we estimate for 2.5 megawatt power, we have 1 ton of energy carbon footprint. So you see that again, these powerful models like Llama 2 is another powerful model which has been used for like a ChatGPT-4 with 34 billion type of parameter, that much 200 tons of carbon emission. So these are two things, significant things with the AI. One is the cost of training and one the carbon footprint. And this is something that we are considering. But at the same time, Microsoft is trying to invest on the hardware type of side, like quantum computing. Quantum computing is going to probably help a lot, but is at the earliest stage. They start investing, and they want to invest the investment every year. They want to double the investment. So that's the plan. Next year 2 times, and then the year after 4 times, 8 times, 16 times. This is the plan that they want to invest and then help with this training and this type of thing. And the other thing that probably is out of your interest, the job opportunity is going to increase, especially if we look at the AI PhD graduate, that they get employment in the United States and Canada. It shows the trend of the PhD graduate in industry and academic. So industry, you see that is going to increase. So there are more demand for PhD graduate in this area, and this trend again is going to increase. So if you are doing AI, there is a good job opportunity. Even for some position, they may lose the job, but for the AI, it seems there is a good opportunity there. So these are some of the trends, and most of the people expecting this trend is going to continue in everywhere in terms of the investment, in terms of the computer power, and the other things is going to increase. And the next, what's happening next? So in the future, they are thinking about having artificial general intelligence, or AGI, because currently whatever we have is mainly design a model specifically for special application. Like ChatGPT cannot do that much mathematics. It can help you with the text. It can help you with some converting text to image, something like that, but they cannot use for other application. Or sometimes we do some project. I'll show you some of the project that is specifically trained for special purpose. So now they are thinking to have a AI that can handle general thing, not only designed for special purpose, it is more general. To do that, we need to go through these different steps, 5 steps toward that, and this is from this website. And then they said super AI AGI to outperform the human capability. So how it can outperform now? At the moment, we can see that AI can do conversational, so you can talk and they can understand you, communicate with you. So you are at this stage. Then reasoning AI, we can see some application like computer playing chess, and sometimes is competing with the first champion of the chess. So that's reasoning. Some application there is, but not for all of them. It still needs to be work in this area. Autonomous, we see autonomous vehicle, and then there are some agents, AI agents. They can operate autonomously without user interface, without user input. But again, is not that much extended. For some application, for Google Taxi, we can see that, but for bus, not yet, or some other application, not yet. So these are still, there is work needs to be done in this area. And then innovation. So AI, they are not that much innovative. Still, and they can generate some knowledge, but the wisdom is missing in AI. Here we need wisdom, and then we need some people to have some innovation, and then prediction, critical thinking. So they want to see whether AI can reach to a PhD graduate in terms of critical thinking or not. And then finally, organizational AI. We want to reach to the stage that AI can take care of the whole organization without human inside. So imagine AI is managing the university, try to program, try to find what is your courses next semester and all other things. So this is something that they predict in 20 years. Some people, they are optimistic, some people maybe 50 years. So these are some sort of the trend that is very important and a very hot topic in AI, that they want to come up with AGI. But lots of work needs to be done. Yeah, so one of the projects that I want to talk about that is eye tracking, which we have done during the past years. The idea is detecting lazy eye, which is mainly called amblyopia, is happening at an early age, and if we can detect this issue, we can easily treat it, sometimes by exercise, sometimes by training, without doing operation. So we've been working in this project. For this project, we need to take the video of the person, try to record the video, and then, of course, detecting the face, and then detecting mainly segmenting the face, eliminating the background, and then doing the eye detection. So this thing we have done mainly automatically, and this one now we can do with semi-automatically. With the software that is available, we can click and then take that. But we want to make everything automatic and then using the video to do that. So some of the results that we've done, we have been able to mainly eliminate background as much as possible, and then do some sort of extra algorithm to detect circle in that one. So this has been done fully automatic without any intervention. And the main thing, we want to have a small and efficient size network, not a big network. So there are some results that we've got about 80%, 85, 90% accuracy. We can achieve that one. But and then we try to use Raspberry Pi as an embedded system, because we wanted to develop a glass, put a camera next to the eye and a light source next another part, and then try to capture the eye movement. We did that one, and then we be able to track the eye using the Raspberry Eye camera, and this is the movement in the X direction. So how far is going, and then we can compare the movement of two eyes, and then see, and then with also ground truth, see if there is any issue, we can address that. And now there are some powerful software like SAM2 metadata. You can see this software that you click on one object in the movie, and then it will follow that object through the whole movie. So they are powerful software, but this SAM2 is, I think they make the code available in GitHub. You can have the code, but it's required lots of computational power, or probably we cannot install it on the mobile app at the moment. So yeah, this is one area that we are interested to track objects. One in the eye for that application, and another one also which is related to eye. Instead of looking at the front part of the eye, we can look at the back part of the eye. This one is using machine stereo matching superpixel algorithm to segment abnormalities in the optical disc. So these are optical discs. There are two optical discs at the back of the eye. So if we have the image, this image is mainly called fundus image. It will capture by optometrists using optometric device, and then we use these images to. So this is categorized as a normal. This one is mild, and this one is severe or advanced glaucoma. So we train the network using these images, and then try to detect glaucoma as soon as possible, as early as possible, because there is no pain, is a silent killer. Just when it happened, we have blindness. We cannot see that so we lose the eye. So this is an important type of aspect that we can look at that using AI and using deep learning algorithms, using super pixel segmentation. So we have done some work in that area, and we've got the data from the optometric clinics, and then we published one article in our world journal related to that. And one interesting thing that when we are using these images for glaucoma detection, but sometimes AI coming up with another finding. So we have seen that AI can find the gender through this type of images. So this is something unexpected. Or another application I've seen, dentists, they have X-ray of the dental, and then the AI can detect the gender from the X-ray of your teeth. So these are something that unexpected outcome can be happening from the AI application, which is interesting. So this is they see something that we cannot see probably. And yeah, that's one thing. Another thing that we've been working on that, and advancement in melanoma diagnosis. This is the project that we are going to collaborate with Gonzalo team, and then we will work more on that. With the melanoma, the reason that we selected because New Zealand and Australia are among the most susceptible country towards skin cancer, because one of the factors of skin cancer is UV, and the UV is high in these countries. So this shows the number of people that die every year in terms of population is huge. And yeah, that's mainly one reason. And then there are some symptoms apart from exposure to UV. There are other type of parameters that play role in terms of skin cancer. And normally, how they detect skin cancer, we need to go to the dermatologist, and then they look at ABCDE rule. So they check these things in the mole. If they found anything related to these symptoms, so they come up with that diagnosis, and then they send it to biopsy for the confirmation. And normally they use expensive devices. So these are some of the devices that they are using polarized light, or using multispectral light, LEDs, different LEDs to penetrate at different level of the skin and to see, or maybe different zooming, or this called nevoscope. And then these days now there are some artificial intelligence also coming to these devices. So they try to have a good view of the skin and the mole and the lesion, and then come up with a better diagnosis. But normally they are expensive, and then we have to see the specialist. So what we've been trying to do, we've been trying to mainly use some machine learning algorithm to mainly simplify the process, and using artificial neural network to come up with diagnosis. So that can be done easily. So we have developed a segmentation algorithm, and then one of the company in Australia, GP2U, which is specialist in telehealth and the streamlined GP patient. They want to have telecommunication. They don't want patient to come and visit dermatologist. So you can use their mobile app, and then the mobile can take the photo of your skin, and then it will do some analysis locally, and then transmit it to the specialist, and they give you some consultation. So that's the product they are doing, and there are some other things that they can do to the mobile. So we have done some work with that company, but that was about 2016, using machine learning techniques. And then later on, we try to use other algorithm, SVM, and support vector machine and artificial neural network to implement it on the hardware. So we wanted to have a portable device. Instead of having expensive device, we can use this type of board, Zinc. At that time, we used Zinc ultra-fast FPGA board. And then we managed to implement this type of classification on the board. So that board is not that expensive, and they are using just normal camera or with a special lens that can be attached to the mobile camera, and then we can come up with the decision. And then we found that there are more challenges with this diagnosis, especially from one person to another person. The skin color is changing. There are sometimes hairy objects, sometimes the poor illumination. So it needs more work and more improvement. So since 2018, the convolutional neural network was getting popular, and then we applied convolutional neural network to this project. And then we mainly also examine the data augmentation, because for the training of the artificial neural network and CNN, we need lots of data, and then we use data augmentation to generate more data without getting consent and going to the patient. And then we mainly try to do some extra pre-processing and extra segmentation, then apply to the network. So this is one of the networks that we design, and then we try with different scenarios, one just the raw image, one the after hair elimination, another after segmentation, and then we try with different type of parameters of the network to see which one is more efficient. So through the type of different experiment, we ended up with a design which is not that much complicated. The idea was mainly to have a lightweight, smart, and less complex network to be able to train fast and then implement it on the hardware easily. So now we are trying to implement on the mobile phone. Even some mobile phone, they cannot handle big network because they have ARM processor, and the ARM processor can we convert the application from MATLAB to the mobile app, but it's not be able to transfer the compilation to the network. So the idea is to try to come up with lightweight and less complex network, but the accuracy, we want to have a good accuracy and keep the accuracy up. Yeah, so we use some of the database for the dermoscope image, and then we try that network with different type of situation, raw data, denoise, and segmented. So we've got a good accuracy, which is, you see that the network is not that much, even probably less than 1 million parameter. When you compare with the networks of billions of parameters, they are not that much complex, but they come up with a good accuracy. So that was one of the idea. And then another topic that we are working on that is mainly, I try to go quickly through that. Another area that we've been working, and we can work with Gonzalo team, they are working on the food and weight assessment estimation. We have done some work on the fruit detection and then quality inspection. So we can have a dish of fruit, and the network has been trained with maybe about 8 different type of fruit with lots of images. So it come up with a decision what type of fruit it is. And also we do some processing to identify the quality of the fruit through the color and through the shape. So we have done that project, and then hopefully we can integrate that one with whatever Gonzalo is doing, and then come up with a better more information. Especially it's good to calculate the calorie that we take every time we have a food, and then we want to see how much calorie we take, and then we have some advice what exercise needs to be done. So these are some area that has been used a lot in combination of image processing and deep learning neural network. So we see that is not that much scary AI. At least for us, we try to use the good side of that, and then try to help with better diagnosis in the healthcare, reduce healthcare cost, and then, as I mentioned, one problem with the with the AI, we need lots of data, but at the same time, we have algorithms that they do data augmentation, generate data from small size, and then we can use that one. So more talents are entering into the field of AI, which promises the drastic growth in the number of AI innovation and applications. Hopefully you are one of those that you can bring more talent, and then bring more useful application to this field. Thank you very much.
Thank you, Hamid. We have time for some questions or any questions.
I have one question.
Yes.
Some translate
Okay.
for help. Well, first of all, thank you very much for your presentation.
Thanks.
I would like to ask if you have rigorously analyzed the generalizability of the results with real-world data.
Frequency analysis of what?
I would like to ask if you have rigorously analyzed the generalizability of the result with real-world data.
Oh, with real world data, with the skin cancer, or with which one?
With segmentation task.
Segmentation.
Yes.
Yeah, with the segmentation, normally the real data, we take the image from the maybe mobile phone, or we take the mobile phone camera. That is the real image when we use the real image. Or sometimes we had vital sign monitoring. We took it to the hospital and then set it up in the hospital and then connected the device to the patient. So we had ethical approval to go to the hospital and then attach our equipment to the patient and then collect the real data. So first we mainly use the database and we develop algorithm, and then when it comes at a certain stage, we want to validate with the real data. And for real data, normally we have to have ethical approval, and then we apply for ethical approval, and then sometimes we recruit subject. We ask people to come to the lab and then collect their information. Sometimes we go to the hospital and then get permission and then collect some data from patients. Yeah, some of them we already have the real subject, and with the skin image also we have a collaborator, dermatologist collaborator. He was taking the image in his lab, his lab, and then he was providing us the image for us to do the diagnosis and to do the detection.
Okay, thank you.
Thank you.
Thank you again for your. So, what was your main challenge on the choosing of a neural network for the melanoma classification?
Yeah. The main challenge, because there is no certain procedure to select a network. So sometimes you select an existing network like ResNet or like other
AlexNet.
From MATLAB. You use that one, and it gives you some information or some result. But when you want to implement this one on the hardware, you see it's too big. So it's lots of parameters. And so that was one thing that we got some idea, but we started from scratch almost. We put the blocks together, and then we add some layers in each block, and then we start playing with the parameters of each block. So how we can improve, and then start by changing the number of filters, this filter size, what filter size should be, what kernel size should be, what sort of function we have to use. So normally it's not a straight way that we can do that. We need to do some experiment and then fine-tune the design. But as I mentioned, one of our main goal is having a very simple and not complex network. Otherwise, there are very good network. We can use them, and like Google Net, it can recognize 1,000 different subjects because it has been trained with lots of images. So it can recognize up to 1,000 images. But this is a big network. Or the segmentation, I'll show you. There is good segmentation software, but again, is specifically sometimes designed for special applications. Sometimes they are too big to be integrated in the mobile app or some hardware things.
I have worked on DenseNet. I don't know if you know it. Yep, and it's pretty difficult to tune it because of the amount of layers.
Normally we use MATLAB for the deep learning the algorithm in MATLAB, and then there is an option to add extra block or remove one block. So that is always helping us to come up with a better. But sometimes you can use the existing network. That also good. But in terms what application are you looking for? Do you want to have to implement it on the hardware, or it's okay you can have in the computer, you can have your PC running on the PC, there shouldn't be that much problem. Yeah.
Thank you very much.
Thank
you. Do you perform any post-processing that has proven useful in segmentation tasks?
Post-processing?
Yes.
Post-processing, no. Normally we do pre-processing, and then we do segmentation, and then we apply to the classification. We sometimes in terms of blood pressure, we need to normalize, or we need to do something after that. So that may be necessary. But for the image, we don't do that normally. Okay. As long as the classifier comes with the decision, we use that decision. Maybe for some application like blood pressure, because it needs to come with the estimation, and then sometimes you need to do something as a post-processing to check the level of the knowledge that you get, the level of the accuracy of the output. Is that right?
Okay.
Yeah.
Okay, hi. Thanks again for your presentation.
Thank you.
So, since you've been quite successful in performing these applied engineering projects, so is there some from the faculty level or the university level any incentives in producing licensing or patenting or producing spin-offs or startups, this sort of things?
Yeah, the university, we have a center, AUT Enterprise. They will help researcher to lodge a patent application. For one of the algorithm for skin cancer, they help us to file a patent application. So we need to get funding, and then they will help us to do that. Yeah, normally they encourage to apply for patent and later on for commercialization purpose. We did We did actually 3 projects. The one that I did with GP2U, we had agreement and we sold the license of our segmentation algorithm to that company. So through that office, we sold, I think, more than 100,000 Australian dollar. The algorithm, we sold them, and also there was the royalty issue with that, so we had the royalty. So yeah, some of the algorithm, we can do that, licensing. Or another application I show you briefly was vital sign monitoring. We had funding about $2 million from the government, but it was joint between the government and the company. So then when we finished the project, we gave everything to that company, so they start to integrate that project with their product. That was also another successful thing. So we didn't get any patent or anything, but we got the funding first, and then we produced whatever we developed to them, and they integrated. They had, they are a big company. They are having lots of application in healthcare, and they included our thing with their smart databases.
Yeah, thank you.
In the start, you talk about the Raspberry Pi for the study of the glaucoma, and then you talk to get low cost to make the machine to study the other study you do. How difficult is get the lower cost to make the motherboard for this? How far is the motherboard of the Raspberry Pi?
No, the Raspberry Pi is coming with its own its own board. It's small board, and it has also inbuilt camera. You attach the camera with the cable ribbon to the board. We use nano Raspberry Pi, nano one, and that was a very small thing. And then even we were thinking to implement on part of the glass. So we designed a 3D glass using 3D printer. We printed, and then we put that camera with that glass. And then we want to, even with the micro Raspberry Pi, you can put it on the frame of the camera. So it's not that much big issue. Or sometimes you just have the camera here, and with the cable you connect it to the body. You put some to the pocket of the jumper. Because they need also some power supply and other things. The reason that we are doing that, again, there are some products that they are using, but they are expensive, more than $10,000 when you want to collect that information. But when you design your own glass and when your own board, it will be much cheaper.
I have a question, maybe it's related with that one, because in some of your projects you try to reduce the size of the networks. And my question is about the workflow of this design. You start for a really complicated network and then start to reduce the size while trying to achieve some level of accuracy, or is the other way around?
There is a process in deep learning design. Sometimes you come up with a network, and then you start taking up one block, and then see how much you lose accuracy. So you can try that one, or sometimes you remove, you change the one parameter or reduce the filter size. That's right. We started with the bigger one, and then we try to remove one block, see how much we lose the accuracy or how much we lose the performance.
Okay, thanks.
Thank you. Thank you for your presentation. And I have a question related with the models. The models are available for everyone, or
Which models? Which one?
the models you talk about? For example, the model for melanoma.
Mm.
You create a network, right? But this is a model, and this model is available for everyone.
No, there are some application you can find, like a mobile app. There are some application that they make it available, but they are not certified. Sometimes,
okay.
yeah, you can use some of the application, but I think when there is another process when you have the product, then you need to get the approval, like FDA approval.
Okay.
So FDA approval sometimes takes 1 year, 2 years. For some of this equipment, even more than 2 years.
Oh.
They need to provide document. They need to provide testing, evaluation, lots of information, and then when it get approval, then they can sell the product in commercially. They can sell it that. But I think at the moment, there are some application even with the smart watches and some other things that they do some assessment, but not clinically approved. Exactly. Yes, yeah.
Okay, and I have another question. It's about segment anything model from Meta.
Yeah.
Because it's really, really powerful.
Yeah.
And this model helped you a lot in your.
No, we haven't. I saw 3 weeks ago they released another model of SAM for medical application. So like MRI image, you can select one tumor or one part of the image, so it will track that through all the image scan or all video. Yeah, it's very powerful software, and especially for segmentation, and they are having also for medical application. Yeah.
Okay. I think that is all. Thank you. Thank you so much.
Thank you.
Thank you.
My last question. Do you know if energy consumption has increased due to the deployment of your model in clinics, and how has it affected them?
Can you please repeat one more time?
Do you know if energy consumption has increased due to the deployment of your model in clinics, and how has it affected them?
Yeah. Energy consumption is sometimes depends on the GPU and the processing power that you have.
Yes, I know.
So whenever you run on the PC and when you run on the machine with GPU, the processing time is much smaller, and the energy consumption will reduce. So it's not there are some also algorithm when you have a hardware like GPU, like a FPGA board, you can measure the energy consumption, but it's not. It mainly depends on the platform that you are running your algorithm. Sometimes when you have a powerful machine, probably is running fast and the energy consumption would be lower. But overall, it depends on the number of parameters of the network. When they look at the energy consumption, they see how many million parameters are in this model. Based on that, they can have some estimation. But again, it's not just a direct relation between parameter and the energy consumption. Even some of these powerful models, I've seen they do something that they reduce the energy and they reduce the CO2 emission. So there are some way that they claim that they have less energy and less CO2. Yeah, there should be not one parameter. There are lots of things that they can work to reduce the energy consumption. Yeah.
Okay, thank you.
So as discussed just today, I'm quite interested in the embedded systems perspective, and some of my students are here.
Yeah.
So you mentioned about the FPGAs. So are you still using FPGAs related to machine learning or tiny machine learning? And what is your vision about the use of embedded systems in, let's say, more sophisticated machine learning methods?
Yeah, the good thing about FPGA is doing parallel processing. You can do parallel processing, and then especially for image. We had a project. I wasn't directly involved. That was related to satellite image, that they got image from satellite. So lots of information collecting from the satellite dishes, and they had the FPGA type of platform to process this image and then come up with the idea. So I think in that regards, when you have lots of input to the system, FPGA would be useful. We haven't implemented any of these. Only we've done the support vector machine. We use that one, and we use a Xilinx chip for that. That was good. That was successful.
So more classical machine learning algorithms maybe are more suitable for FPGA implementations, but probably deep learning.
Deep learning, I haven't seen that.
GPU domain.
Yeah, I haven't used that one for the FPGA.
Okay.
Normally we use GPU for that.
Definitely.
Deep learning. Yeah.
Okay. Thank you.
Okay. No more question. So let's do thanks to the professor for the
Thank you.
Thank you very much for your attention. Well, if you want, you can take it out. Over there, no? Thank you.